Hello class, this is a video tutorial on linear functions part 5. In this video we will be looking at the properties of parallel and perpendicular lines. So pairs of parallel lines never intersect and have equal gradients. So I've shown a quick diagram here. Here we have a plane with the function f and the function g. They're both linear functions, m1x plus c1 and m2x plus c2. Okay, in this case the gradients m1 and m2 must be equal for them to be parallel. However, just take note, if c1 equals c2, then the two lines are actually the same. Pairs of perpendicular lines intersect at a right angle and have gradients whose products equal -1. So here we have, once again, two linear functions, g of x and f of x. If we were to take their gradients, m1 and m2, here we are, and multiply them, the product will become -1. This property here is very important in order to accomplish the next bit of work that we will be doing. So here we go. Given f of x equals 4x minus 3, calculate the equations of the lines g of x and h of x if, so this first one, if g of x is parallel to f of x and passing through the point -3, -7. In case you're wondering what it's asking, it wants the equation of the line. So here is, for example, oops, do this in red. Here is, for example, f of x in red. Okay, what is g of x? Okay, sorry, f of x is equal to 4x minus 3. We want g of x so that g of x is parallel. It's parallel to this, to f of x. But we also have to make sure that the line g of x passes through the point -3, -7. Okay, so well, in order to do this, we need two things. Well, the equation we'll be using is this one, y minus y1 equals m bracket x minus x1. Well, first we need a gradient. Now, if you take note, g of x needs to be parallel to f of x. We just saw in the previous sheet, for them to be parallel, the two gradients must be the same. Well, in this case, m1 equals 4. That must mean it's the same as m2. Okay, because the gradient of g of x must be also 4. Well, that's all we need. We also now have x1 and y1 for this equation here. Now just a matter of substituting, so we get y minus y1 equals m, which is 4 bracket x minus x1. Evaluating these, we get y plus 7 equals 4x plus 12. And now from this point, you can solve this in one of two ways. I will show you first in the gradient intercept form. There we are. We subtracted 7 from the 12. Or we can have it as the general form. So here's one solution, which is valid. But we also have, if we move y to the right hand side, we get 4x minus y plus 5 is equal to 0. And here is a valid second solution. To be safe, I will do both for both examples. But in any case, that is the that is the equation of g of x that passes through -3, -7 and is parallel to f of x. Let's move to the next equation here. Let's find h of x so that it is perpendicular to f of x and is passing through 12, negative 13. Well, we saw in the previous sheet of paper here that for perpendicular lines, their gradients when multiplied give a product of negative 1. Well, we know what m1 is. m1 is here the gradient of f of x we do not know what m2 is, but we do know if we multiply them, m1 times m2 gives us negative 1. We get 4 m2 is equal to negative 1. And so m2, by dividing by 4 on both sides, we get m2 equals negative 1/4. So that is the gradient we'll be using for this equation. And for this, we need the point 12, negative 13. So substituting all this, we get y minus 13 equals the gradient, negative 1/4 m minus x minus x1, which is 12. Let's evaluate some of these. So we get y plus 13 equals, this stays the same. I'm not doing anything just yet. Now I will multiply this bracket out. So we get negative 1/4 x, negative 1/4 times negative 12. Well, 1/4 of 12 is 3. Negative times negative gives us a positive. And copying out the left hand side. Subtracting the 13, this will give us y equals negative 1/4 x, negative 10. And this is one solution in gradient intercept form, but we'll also answer this in general form. So I'm going to multiply everything by 4, giving us 4y equals negative x minus 40. Moving everything to the right hand side, we get x plus 4y plus 40 equals 0. This is also a solution for the question in general form. So I hope that gave you an insight into the properties of parallel and perpendicular lines and a few examples of where they might be used. Hope to see you in the next video. Best of luck.